Hello and welcome to this proof of concept video for the open source NFT and wallet authentication framework for Cardano. This project is designed to simplify decentralized app authentication by integrating secure wallet-based and NFT-based sign-in functionalities. In this video, I'll walk you through the key features, demo app, the authentication process, and how developers can integrate this framework into their projects. Let's get started. The goal of this project is to provide developers with a modular and open source authentication framework for Cardano decentralized apps. It enables authentication through Cardano wallets and NFTs, removing the need for centralized identity providers. Some key features include seamless wallet and NFT authentication, single sign-on with NFT metadata, membership levels and role-based access, time-bound access and usage limits, fully open source for developer flexibility. Now let's take a look at the live demo application where you can see the authentication framework in action. The demo app is deployed at boilerplates-e-versal.app. This demo application currently supports traditional email authentication, wallet authentication, any NFT authentication, and SSO NFT authentication. What wallet authentication entails? Wallet authentication involves signing up using your stake address. The NFT authentication allows you to utilize any Cardano native assets in your wallet to register for the demo application. This authentication can be deactivated by the platform owner to require specific policy IDs upon registration. Final method is SSO NFT authentication. SSO NFT authentication is more intricate. It is triggered only when a specific policy ID is received. Subsequently, the metadata of the asset is retrieved for the further authentication process. Let's go to the sign-up page. As you can see, our application currently supports traditional email and password authentication and also the wallet authentication side. Let's disconnect to see all the wallets we have. Currently, you are seeing all the wallets that are installed on my browser. We support every CIP30 wallets. Let's continue with Eternal. When you connect your wallet, you can sign up with the wallet address, or you can sign up with any assets. As you can see, I have my other handle here, or you can request a demo token. Let's switch to my pre-production wallet to see more NFTs here. We disconnect and reconnect our wallets, and as you can see, we have more NFTs and more options where you can see the SSO tab. The SSO tab means the application automatically recognizes specific policy IDs of the assets and puts them under the SSO tab. So when you click any of these, you sign up into the SSO authentication process. First, let's go with the sign up with wallets. I am asked to sign a message here. As you can see, we have signed up. Now we have to log in with the wallet. I will sign a message again. And now we're in. Let's go to the framework demo. This is our demo main page. As you can see, we have written what our package can do here. And let's start with the asset display. As you can see, we have the assets of the CIP30 wallets. We have their policy IDs, the amounts, and the asset names here. Let's go to token access page. This page gives you access if you have other handle or Hosky NFT in your wallet. If you have any of them or both of them, you can access these pages. Let's go to the metadata display. As you can see, we we did not sign up with us SSO NFT, we cannot use this page. We will come back to it later. And the metadata access shows that if we have a specific role in our metadata, our user session will get these roles and we will be able to access these pages. Now we will use a different way of signing up. So we need to go to our user page and delete our user because we already have a user in our database with that specific wallet, and if we try to log in with, let's say, another NFT with the same wallet, we will be rejected entrance here. So let's go back to our mainnet wallets where we had our other handle. Disconnect and reconnect. Yeah, let's sign up with our other handle. We have created our account. Now let's log in. Yep, we're in again. Let's go back to the framework demo. As you can see on our assets page, we have our other handle. Let's go to the token access page, and since we have the other handle in our wallets, we can access this page. As you can see, this page is only accessible to holders of other handle. We still cannot use this page as these are related to SSO NFTs and we still don't have role. Now let's try to use an SSO NFT. When we use SSO NFTs, we don't have to go through the sign up process. We can directly go to login. Let's go to our wallet. Just to show you what's the difference, let's try a game changer NFT, which is not an SSO NFT. I signed up the message. As you can see, the user not found. Let's try to use an SSO NFT. Let me sign the message. And we are in. We have our user page, which is created today and last updated today. This is our wallet address. This is serialized. And in the account information, as you can see, we have two roles. When we go back to the demo page, I will explain them in more detail. Let's go to the framework demo page. You can still see our assets here. They come from our wallet. Since in this pre-production wallet we don't have any of these NFTs, we cannot access these pages. And let's come to our metadata display page. The right side of the page comes from the metadata of this SSO NFT. As you can see, we have our policy ID, we have our unique identifier, the issuer. We have this Boolean value of if it is transferable. It is important if we have a tied wallet, which is testnet wallet address. We have our usage limits. We have our Boolean value of if the inactivity period is enabled. And if it is enabled, what is the time limits? As we can see, this is set to 30 days. We can see when this NFT is created and when it expires. And we have our roles, and we have the Boolean value if inactivity period is passed, and as you can see, it is not passed. And this is the value of these are the values from our database. We have the policy ID. As you can see, this is the same. We have the usage count, which is 1 for now because we just created our account. This is the last use time, which is a couple of minutes ago. We can see the tied wallet address, the created and updated dates, and the admin and reviewer roles. These all came from when we signed up with the NFT. Let's see the metadata access page. As you can see, we have those roles here. We can access these pages. Let's go to the reviewer page, and as you can see, this is only accessible to users with the reviewer role. Let's go to the settings page, which is also hidden behind the role access. This is the settings page. We have these policies already set up in our databases, and these are the SSO policies list. This list tells our application what NFTs are SSO NFTs and what are not. And we have our unique identifiers. As you can see, we have 3 of them here. And we have our user list. This is my mainnet wallet we used to show the demo part of the application, and this is the wallet we are currently using. As you can see, we have 2 roles. With the mainnet wallet, we don't have any. This is the end of our showcase of our demo application. Thanks for watching. Now let's take a look at how this framework operates under the hood. We will first focus on the authentication functions, and we will start with the non-SSO authentication, specifically focused on wallet and assets. When a wallet connection occurs, we send the relevant data to our backend function, and first we verify the wallet ownership with the signed message the front end sends. If this message signing process fails, we return false. And then we check if this is an asset authentication. What we mean by asset is NFT or token. If it's not an asset authentication, we return true since we verified the ownership of the wallet. And if this is an asset authentication, we then check the authentication policies if the app provided, and if it's a strict policy and the policy ID of the authenticating asset mismatches with the app's policy IDs, we return false. If we pass it or we are not in a strict policy, we check the asset ownership with our Blockforce API. And if we cannot verify the asset ownership by the specific wallet, we return false. And if its ownership is verified, then we return true. Now let's check how the SSO authentication mechanism works. We get the wallet connection and the relevant data from our front end, and then we verify the wallet ownership. If fails, return false. And then we check the asset ownership on the blockchain with our Blockforce API, and then we check the SSO metadata version. We currently support our first version. If it's in a different version than ours, we return false. Then we check the expiration date, and then we check the issuer and the unique identifier, and then we come to the if it is transferable. If it's transferable, and if it is transferable, we automatically go to the next step, and if it is not transferable, we check the wallet address, and if it succeeds, we continue to the next step. And if the usage count is enabled, we check the max usage number, and if it succeeds, we go to the last step, which is the inactivity period check. If the inactivity period is enabled, we check the last time the users logged into our app, and if it checks, we return true. We'll talk about our front-end components, and especially the wallet provider. This wallet provider is responsible for handling the wallet connection, getting wallet details, and sending them to the backend. As you can see in our Next.js application, we have our wallet provider wrapped around our app, and here you can see we wrapped it around all our application. When we, for example, check the login page, we are importing our use wallet hook, and with different functions like sign message, which we use to ask the user to sign a specific nonce to check if they own the wallet, and the assets interface, which we use to process the assets. Here we use the use wallet hook to get the is connected boolean value, the connected wallet name, connected wallet, which is a wallet object, or null. We get the network ID, either 0 or 1. We get the addresses, which usually is filled with only one address, which is the stake address. We get the assets array. We have the decode hex to ASCII, which is to get the asset name from the hex of the asset name. We get the currently available wallets. We get the connect wallet and disconnect wallet functions. We use these functions to connect to our wallets or disconnect to them and get the details like assets and vice versa. And this is the wallet context from our package. This is where we handle the connection to the CIP30 wallet, disconnection to it, and the information like assets is connected, the network ID, the addresses, and etc. Here in GitHub README page, you can see how to set up our page in your Next.js application. We explained in details how to create the context, how to wrap it around your app, and we have also put all the functions and the types we use in our package. For example, this is the client types and return values and the functions. As you can see, the asset, the wallet, and the wallet context prop interfaces. And here is the use wallet hook we showed you before. And as you can see, the utility functions like connect wallet, disconnect wallet, decode hex to ASCII, the sign message, how to use them, what to expect from them, and what to send to them. And here is our SSO metadata standard. This is what we decided to use on our package. You can see we have our version, the unique identifier, the issuer, the issuance date, the expiration date, the transferability check, the tied wallet, the max usage enabled, max usage number, the inactivity enabled boolean, and inactivity period. Also, we can have an array of roles here, which our packaged SSO function can read and return these values to your app. Here are the server types, return values, and the function descriptions. Interfaces like sign-up options, login options, the SSO options, like the user object, the sign-up result, and etc. Three authentication functions, the sign-up user, login user, and the SSO authentication. We showed you in detail how these functions work. And here you can see what they expect from you and what you can expect from them. Also, we have the utility functions to use in your authentication mechanism, like you can use generate nonce, the verify wallet address with the signature. You can use our hash password, validate email, and you can also use the validate password functions. When you use the asset verification and the SSO, you also need to set up your block first API keys, and you can set them up in your application. Our package can use them. You have to set it up like that. And the next functions, as you can expect, uses block first API. We have verify asset ownership. This verifies the ownership of the specific assets with the wallet address. We have verify asset policy. It verifies if a policy ID exists in the asset associated with the wallet address. We have the metadata reader, which uses block first API to read the metadata of the specific asset and return the metadata values to your app. We set up a simple example usage. You import our hook and you can use these values from the hook. As you can see, you can make a wallet connection and disconnection functions. You can display the assets. You can use decode hex to ASCII function to update the wallet assets names. As you can see, this shows the hex number and this shows the asset's human readable name. And here is an example of how to use our package on the server side. You can use the sign up user or login user functions or the SSO function. You can all read through these document on how to use our functions and the package. During development, we encountered several challenges, including the CIP30 wallet integration issues, especially serialization issues in Next.js app router. The Cardano serialization library does not work perfectly with the Next.js app router, so we had to write our own serialization and deserialization functions to get the UTXO data from the CIP30 wallets. We worked really hard on creating an NFT metadata or our authentication package, and we decided to leave session management and data persistence to developers of apps in order to make this package useful for a wide variety of scenarios. That wraps up our proof of concept for the open source NFT and wallet authentication framework for Cardano. If you are a developer looking to integrate secure authentication into your decentralized apps, please check out our GitHub repository and documentation, explore the live demo, contribute to the project and provide feedback. Thank you for watching, and we look forward to seeing how you build with this framework.